Look at this autonomous vehicle navigating complex city streets entirely on its own. We tend to assume the intelligence driving it was born inside a pristine, multi-billion-dollar Silicon Valley campus like this one. But a raw algorithm doesn't know what a street is. It is completely blind and deaf, lacking any understanding of our physical reality. To make sense of the world, these models rely on human-in-the-loop labor. This flowchart shows how chaotic raw data has to be manually checked and verified by a human being before it forms a structured pathway the machine can actually use. Intelligence, artificial or otherwise, is not something you can just conjure out of thin air. It is a manufactured product, and it requires a massive hidden supply chain of human labor. If we trace that supply chain back from California, the data travels across the globe, landing in South Asia. But it intentionally bypasses the famous tech megacities and expensive corporate hubs you might expect to see. Instead, the pipeline routes directly into smaller, historically industrial centers, like the town of Karur in Tamil Nadu, India. While the servers sit in the West, the data itself is processed by this localized, small-town workforce. Inside a Karur annotation center, hundreds of workers sit at monitors, essentially operating as human processing units. Their daily routine involves highly specific, repetitive tasks. This motion sequence shows how a digital bounding box is manually snapped onto a moving car, which is exactly how you teach a vision model to recognize a vehicle on the road. Then there is semantic segmentation. Workers take complex street scenes and meticulously break them down, pixel by pixel, labeling the sky, the sidewalk, and the pedestrians. To teach natural language processors how to comprehend regional accents and dialects, they perform audio-text alignment, listening to thousands of voice clips and transcribing the exact phrasing. They even record egocentric video logs. Workers literally strap cameras to themselves and film their daily chores, like folding clothes or opening doors, to teach autonomous systems how human bodies move through physical space. Every single click, tag, and label logged in this room serves as the foundational intelligence for algorithms deployed around the world. Look closely at these hands operating a traditional wooden loom. For decades, Karur was defined by heavy industry and textile production. Over the last few years, those mechanical looms have been rapidly replaced by this digital assembly line. Historically, youth faced a strict geographical ceiling. This map tracks the brain drain, graduates forced to leave rural Tamil Nadu for major cities like Bengaluru. The recent annotation boom offers a local alternative, securing competitive salaries without the high costs of Tier 1 cities. This geographic pivot allows local college graduates, particularly young women, to build viable digital careers while staying close to their families. By keeping capital and talent within the region, this shift in where technical work happens is altering the economic trajectory of towns like Karur. Despite the current economic high, industry analysts are raising an uncomfortable question. How long will this entry-level boom actually last? Advanced models are increasingly relying on synthetic data. This diagram illustrates how two AI nodes can now feed generated information back into each other in a closed loop, completely bypassing human input. As those self-supervising techniques improve, the sheer volume of manual tagging required to train a machine will inevitably plummet, which means these dedicated young workers might be carefully constructing the very algorithms that will one day replace their jobs. The digital assembly line has delivered immediate upward mobility to rural hubs, yet its long-term survival is directly threatened by its own success. But human labor is not entirely obsolete just yet. Self-training models still have severe built-in limitations. Even the most advanced systems routinely stumble when faced with rare edge cases, complex cultural nuances, and broad contextual clues that a person understands instinctively. When a machine hallucinates or generates a synthetic error, human judgment is actively required to step in, audit the material, and correct the course. The term artificial intelligence feels less accurate the closer you look at it, because behind every algorithmic breakthrough, there is the meticulous, invisible human touch of workers in towns like Karur.